Every single time you go online, you're relying on this system that you probably never even think about. It's this invisible, silent engine that makes the entire web actually usable for us. So today, we're going to pull back the curtain and unlock the secrets of that system. We're talking about DNS. All right, so let's get right to the heart of it. On one side, you've got something we all get, right? A simple website name. But on the other hand, you have what computers actually need to find each other, this long string of numbers called an IP address. See, we like names. Computers, they need numbers. So what's the deal? How do we connect these two worlds?
And that, right there, is the big mystery we're going to solve today. I mean, how on earth does your browser take a simple name you type in and, poof, find the one correct number out of billions of possibilities? And it does it in milliseconds. It seriously feels like some kind of magic.
But of course, it's not magic. The answer is actually pretty elegant. And it all comes down to something we can think of as, well, the Internet's phone book.
So, let's crack open this phone book and see why it is absolutely essential to how the Internet works. Okay, so this phone book, its official name is the Domain Name System, or DNS for short. And its one job, is to be a translator. It takes the names we understand and turns them into the IP addresses that computers need. Seriously, without it, we'd all have to memorize long strings of numbers just to check our email. Can you imagine that? No thanks. But it wasn't always this slick. Way back in the early days of the Internet, things were messy. Every single computer had its own little local address book called a host file. And yeah, that was fine when there were only a handful of computers. But as the network exploded in size, it became a total nightmare to keep everything updated. It was slow, it was clunky, and out of that chaos, the global DNS we know today was born. So how does this whole lookup thing actually work step by step? Let's follow the clues. We're going to trace the journey of a single request from the moment you hit enter to its final destination. Okay, so you type in a website and hit enter. What happens next? Well, first, your computer asks a special server nearby called a DNS resolver. It's basically asking, hey, where do I find this site? Now, the resolver probably doesn't know the answer off the top of its head, so it goes to the top, to a root server. The root server says, I don't know, but I know it's a .com, so go talk to the .com server. So the resolver does that. It asks the .com server, which says, okay, I know who's in charge of that specific website, go ask their server. And finally, the resolver asks that final server, which has the actual IP address. It sends that answer all the way back down the chain to your computer. It's this beautiful little chain of referrals. And that really gets to the core idea here. Like this quote says, no single part of the DNS system knows everything, not even close. Each server just knows one tiny piece of the puzzle, and then it knows exactly where to point the request next. It's this incredible, distributed system where everyone just does their small part.
Okay, so that's the journey for just one lookup. Now let's zoom out a bit and look at the bigger picture, the brilliant way this whole global system is organized.
Let's take a look at a real domain name. The secret here, and this is kind of weird, is that DNS reads it backwards, from right to left, so it starts at the very end with .uk, the top-level domain for the country. Then it moves left to .ac, which stands for academic, and then it finally gets to the specific domain, computer science. It's structured just like a file path on your computer, with folders inside of folders. It's a perfect hierarchy.
And this is really the secret sauce that makes DNS work so well. It's a huge global database, but it's completely distributed. There's no one single server holding all the answers that could be attacked or could fail. Instead, the responsibility is handed down the line. Every domain is in charge of its own little corner of the Internet. And that's what makes the system so incredibly resilient and able to handle, well, the entire Internet.
All right, so that whole step-by-step process is clever, but I bet you're thinking what I'm thinking.
Hang on a second. Wouldn't all those steps, all that back and forth, be super slow? I mean, if your computer had to do that entire dance every single time you clicked on a link, the web would feel like it was moving through molasses. And you'd be absolutely right. It would be. Except for one incredibly clever trick. And that trick is called caching. See, your computer, your router, all the servers along the way, they all have a short-term memory. They remember the answers to recent lookups. So the next time you go to that same site, it doesn't do the whole dance again. It just grabs the answer from its memory, its cache, and boom, the answer is instant. But there's a catch. What happens when that shortcut, that information stored in the cache, is just
Wrong. Maybe the website's address changed, or even worse, what if someone intentionally puts bad information in there?
Well, the result is exactly what you'd expect. Any request that uses that bad info is either going to fail completely, you'll just get an error page, or, and this is the scary part, it could send you to a totally different, maybe even malicious website without you ever realizing it. It's a powerful reminder of just how important it is for this system to be trustworthy.
Okay, I know that was all a bit in the weeds, but how does this actually play out for you in your day-to-day life? Let's talk about how you're using and how you can actually control DNS right now.
So, for most of us, right out of the box, we're using the DNS service that our internet provider, our ISP, gives us. But here's the thing, you have other options. You can choose to use a public DNS service, maybe for better performance or more privacy. And then there's this other cool thing called dynamic DNS, which solves a really common problem for a lot of people.
So, why would you even bother changing from the default? Well, think about it. Your ISP can see every single website you look up through their DNS, and they can use that to build a pretty detailed profile about you. If that makes you a little uncomfortable, you can switch to a public DNS provider that promises not to track you. At the end of the day, it's a choice between what's easy and taking a bit more control over your own data.
And that dynamic DNS thing, it's a super practical tool. You know how your home's IP address can change from time to time? Well, that's a real pain if you're trying to access something on your home network from the outside, like a security camera or a personal server. Dynamic DNS basically solves this. It gives your ever-changing home IP address a single stable name that you can always rely on. It's like giving your house a permanent street address, even if it keeps moving around.
So, as you can see, DNS is so much more than just some technical acronym. It is the invisible engine of the internet, the global phone book that we all rely on, and it's all built on a system of trust, which really leaves us with one final pretty important question. Who do you trust to be your guide?